These are notes from Elham's Math 70 for Wednesday, April the 15th, section 11.2, page 642. It is on compound interest. Last time we did simple interest. We're now doing compound interest, and this is the compound interest formula. I just mentioned quickly that for compound interest, the interest grows, or the amount grows much faster than simple interest in general. So for compound interest, you'll get a much greater return if you're the one that's earning the money, but if you're the one that's paying out, say for loans, the compound interest really goes against you. If you were to get a car loan or a home loan, and if you have to pay it back in time, the compound interest is what gets you quite a bit. You end up paying quite a bit more because of the compound interest, and that's how, of course, banks and lending institutions make money on you and me by charging compound interest. The money will grow much faster. Anyway, here's the formula. The amount is equal to the principal, 1 plus the interest rate divided by n. N is the number of compounding periods per year, and we'll see several instances of that, raised to the nt power. This is an exponent. T is in years, so time in years. N is the number of compounding periods per year, and R is the interest rate. So for problem number 1, the principal is $1,200. The rate is 7% compounded semi-annually. So semi-annually means twice a year, so N is equal to 2 in this particular case, and T is given to be 12 years. So plug everything in. 1,200 equals 1 plus the interest rate of 0.07, 7% as a decimal is 0.07, divided by 2 because it says semi-annual, raised to the 2 times 12 exponent. So this 2 is the same as this 2. So notice in the formula this n and this n match, and times 12 years. So this comes out to be 1,200 times 1.035. That's this thing here, raised to the 2 times 12, which is 24. Punch it in your calculator, 2739.99. And now we're dealing with money. So anytime you deal with money, it's understood you always round to 2 digits to the right of the decimal point, because we're talking now in American money, and in American money, the furthest we go is the penny, the nearest cent. So for instance, you should not get an answer as 995 or something like that, or 99036, just round it to 2 digits to the right of the decimal point. And again, we're rounding off, not truncating, not chopping off. So we round off by the usual rounding off rules. For problem 7, P is 9,600, R is 9% daily. Now for purposes of ease, and in this book, they want you to use N as 360. The calculations are a lot easier with 360. But in real life, in banks and lending institutions, they will use 365 for most years and 366 for leap years like the year 2020. But to make things easier on us, they say just go ahead and use 360, so we'll use 360. And the time is 3. So plug everything in, 9,600, that's the principal. 1 plus R, in this case, is 9%, 0.09. Divided by n, and we're using 360 again for n, for daily compounding, raised to the nt, so that's 360 times 3 years. Punch it in your calculator, that's 9,600. This expression in parentheses is 1.00025, raised to the 360 times 3 is 1080. And then punch that in your calculator, $12,575.23. Again, that's rounded to the nearest penny. You should round your answers to the nearest penny, nearest cent, because that's as far as we go here in America. Number 19, P is 22,000, R is 9%, and it says this time compounded monthly. So compounded monthly means N is equal to 12. So you know what N is based on what they tell us. If they say compounded semi-annually, that means N is 2. Daily, N is 360. Monthly, N is 12. We'll have quarterly. Quarterly means N equals 4. Annually just means N is equal to 1, which is the easiest calculation. You don't have to do much because you're just plugging in 1. So anyway, getting back to here, monthly means divide by 12. So T is 7. So the new amount is the principal by formula, 22,000. 1 plus the interest rate, 0.09, divided by 12 because it says monthly, raised to the N times T, so 12 times 7. This comes out to be 1.0075, raised to the 12 times 7 is 84. Punch all this in the calculator, and we get $41,210.44, rounded again to the nearest penny. In problem 21 up here, the problem gives you the original amount, so it's a little bit different. they're not giving you the principal, they're giving you the amount, they're giving you all this other stuff, and they ask you to find the principal. So if you go back to over here, if you algebraically solve for p, you would divide by this whole mess here. So if I divide both sides by 1 plus r over n to the nt, it looks like this. Right? I mean, if you're bothered by this, just pretend it said p times x, and you can divide both sides by x to solve for p. So this mess is like my x. I just divide both sides by that, and it says a over 1 plus r over n to the nt is equal to p. So here we have the reverse. You want to end up with 25,000 in the future. So the language might be, in the future, if I want 25,000 and I can get 10% compounded quarterly for 12 years, how much do I have to deposit now? What's the principal that I have to deposit? So we go from there. The new amount is 25,000. 1 plus 10% is 0.10. Quarterly means n is equal to 4, so we divide it by 4. Raised to the nt is 4 times 12. So this is 25,000 divided by 1.025 raised to the 48th power. Punch that in your calculator and you get 7641.78. So in other words, this is the principal that you will have to deposit today so that it will grow to become 25,000 in 12 years if you can get 10% compounded quarterly. 23 is another problem. Similarly, in the future, you want $40,000. So how much do I have to deposit now is the question. So we have 7.5% compounded annually. Annual compounding is nice because you're plugging in 1. So that means you plug in 1 here, but if you divide by 1, you don't really do anything. And you plug in 1 here, 1 times t is just t. So the calculation is very easy. So I use the exact same formula as I did back up here. So A is 40,000 over 1 plus R is 7.5%, so 0.075. You're dividing it by 1, so it's just 1.075. Raised to the 1 times 35 is just 35. So we punch that in your calculator, 3182.47. And so the idea is that if I deposit $3,182.47 today, under these conditions, if I can actually get 7.5% compounded annually for 35 years, then it means it would grow to 40,000. Then problem 29, we have P is 2,500, R is 9% compounded daily, so again they wanted to use N as 360, and T is 4 years. So punch everything in. So the new amount is 2,500, 1 plus 0.09 divided by 360, raised to the 360 times 4. This comes out to be 2,500, 1.00025 raised to the 1440, punch it in the calculator, 3583.16 for that particular word problem. 33 and 35, those word problems are just a little bit different. You find a new amount, but ultimately the question asks for the interest. So if you want to get the interest, you take the new amount and just subtract it from the principal. That's considered interest. And here's how to do that. The beginning part is pretty much the same as the others. So for 33, the principal is 2,000. The interest rate is 6% compounded quarterly. So quarterly tells me N is equal to 4. T is equal to 3 years. So it starts off the same, 2,000, 1 plus 0.06 divided by 4, back in the formula here, and then raised to the NT, that's 4 times 3. And this comes out to be 2,000 times the stuff in parentheses is 1.015 raised to the 12th. Punch it in the calculator, 2391.24. And now the question asks, what is the interest? So you started off with $2,000. It's grown to 2391.24. So if I subtract this minus this, that's the amount that I gained. That's considered interest. So I take the 2391.24 minus the amount that I first deposited, which is 2,000, and 391.24 is considered my income. That's the interest. So the answer to the problem is 391.24. This is important, especially for tax purposes. So this is considered taxable income, for instance. So if this situation actually occurred, then you'd have to pay $391.24. I'm sorry, that's not what you would pay, but that's the taxable amount. So you'd have to report that to IRS or Franchise Tax Board that this was income. And 35, that word problem is very similar. What's the interest under this situation? So you start off with $15,000. The interest rate is 10% compounded quarterly. Quarterly means N is equal to 4. And time is 8 years. So it starts off the same. The new amount is 15,000 times 1 plus R divided by N. So R divided by N raised to the NT 4 times 8. And this comes out to be 1.025 raised to the 32nd power. So punch all of this out on your calculator. 33,056.35 is the new amount. So how much is the interest? I take the new amount, subtract my original principal. So 33,056.35 minus 15,000. And that comes out to be 18,056.35 is considered interest. That would be considered interest income. And again, for tax purposes, that's what you would have to report to the IRS or Franchise Tax Board. All right, so this is Math 70, Wednesday, April the 15th, section 11.2, page 642 on compound interest.